Hello everyone, this is Thierry from Go Open Technologies. First of all, thank you all for attending today. I'm going to talk to you about how we can use Wyng backups called Wyng to store and restore safe QubesOS state. Hope you will enjoy. First of all, a quick recap on QubesOS default partition scheme. On QubesOS 4.0, there was only one pool for both VMs and DOM0. It was changed in 4.1 to separate DOM0 root pool, which is now a 20 gig separated pool. The proof of concept of today is made like on 4.0. This is what I use like on the Privacy Beast. First of all, we want to know what are LVMs and thin LVMs and why they are relevant inside of QubesOS. Most of you already know that, but it's still important. LVMs are basically block devices. It permits like to have file system that are clonable at no cost. Until there's a lot of divergence between the volumes that are in use. It also permits snapshots, and it does it like really well, in the sense that you can actually QubesOS use it like with QVM volume reverts. It stores like one state by default, which means that if you restart your cube, let's say you shut it down, and you realize that you prefer the state that it was before, you can revert it. The same applies with templates. What is Wyng backup? The Wyng backup is actually a time machine-like differential backup. It constructs and uses metadata to capture difference only based on the actual LVM that is there. Compared to the state that it already has. To do so, it creates snapshots, tick and talk volumes to see the difference compared to the metadata that is there. It permits also to prune backups in time, so it permits you to actually do backups every day right now, and let's say to keep one backup per week, and then one a month, and one a year, let's say, 10 years from now. So basically you can do a full backup only once, and then store only differences of those backup in time. Another thing that is really nice is that it does deduplication. Deduplication in this sense means that, for example, let's say that you have multiple templates clones, with one of those clones having different software installed for different use case. Only the difference between that clone and the original will be saved. So you can actually have multiple templates, copies that you all save and delete locally because you don't need them, and you can restore them in time when you need them back. Same thing for add VMs, which is really useful for development cycles and stuff like that. As a consequence, it saves a lot of space. For example, if we store Linux gateway and Linux workstation, the total backup space for those template VMs will be like 500 megabytes and then 800 megabytes for the other one. So the data that is actually the same for both are not saved twice, just once. Wyng also permits tagging of sessions when you do a send, which means that if, for example, I don't know, in my case it's useful because I store all my backups online for the OEM image, and I only store like one session locally on the machine that is to be shipped to the client. This means that if, for example, I'm releasing a new version for a month, I just have like to tag it and then in the description say what it contains as a change if it's relevant. The current state of Wyng is actually really stable. There is a proof of concept going on right now on encryption. It's the first attempt going, so please give feedback if it's something that you you need. In my use case, I'm not storing anything private on the cloud, but for user backups that would want to be stored in the cloud, encryption is a requirement. There is also no authentication per se inside of Wyng as of right now, but there is integrity management that is possible to be done by manifest and compression that is there. And on my side, I'm doing the integrity validation on top of it. We will cover that in the proof of concept later on. Let's remember also that Wyng is a project by Tasket, Chris Laprise on GitHub. You please reach him out. This is a quick guide. I will not go through it really extensively, but to use Wyng at first, you need to initialize it, which is the first configuration. If we see the first line here with Wyng metadir, a meta directory is necessary to actually differentiate local backups, meta directory. This means that you could send the backup to multiple virtual machine or SSH server or multiple cubes to store different content. Each metadir contains like the list of app VMs, LVMs that you want like to back up, and they don't need to be all the same. After that, you specify which VM pool is there, the destination, which can be, as said there, like a QubesOS, which means that the cube at the destination will be responsible like to connect to the SSH server. Can be SSH also, which I forgot to write there, and local. In the situation that we use right now, it's going to be a Qubes, and actually we use the thin LVM storage there to store the archive. You select the subdirectory, and then here we specified like the compression, which is BZ2, for the need of being able to use those same backup remotely also. There's a proof of concept made on Wyng-backup right now, which is a bash script that permits to restore the content. This will not be covered into this proof of concept, but that would be really useful for other use case. For example, inside of EDS, if we had only like a bash script with the dependencies needed for LVM tools, and that would remove the need to have Python deployed also in EDS. So this is really interesting, and this is ongoing. The chunk factor is defined to 3 here, so that we have a good ratio of the quantity of chunks that are contained in the manifest. You can look the documentation for more information on that, but in our case, we wanted it to be efficient also on the network. So that's why the chunk size of 3 is chunk factor of 3 is used here. The hash type is forced to SHE 256 for compatibility reason. Once again, like EDS will not support Blake 2. The volumes after having the initialization needs to be added manually. Here we give an example like for VM personal private. Let's take note here that we're not specifying Qubes name, but we're specifying LVM names. Here, I covered that. Yeah, here we see like that we can do a send with the duplication. Here I added clean and remap just to make sure in case of volumes that would be removed, so that the tick and tuck snapshot are also removed. This is technical. If you want like to look at it, I would say look at it more in detail. This is just the use case that we used in the current example. You can also use Arch deduplicate after having sent a backup, so that all the volumes that are already in the archive are metadata are all taken into consideration to do the duplication. When we talk about the duplication, basically Wyng is using our link hard links on the file system to refer to a data that was stored in another session on the same archive directory. This is how it reduced the space needed. Here I give an example also to be able to prune. This is really interesting, and we go more in what we need here. Sparse write was added recently. Sparse write is actually used in receive, which is actually the restore command that we use inside of Wyng. Sparse write is actually writing directly into the LVM in question instead of recreating a new volume and putting the data inside of it. So when you are receiving volumes from local archives, let it be LVMs like in our use case, sparse write is increasing the performance really highly, which is really interesting for us. But if we want to restore DOM0 root partition, what can we do? Wyng can be run from a live USB boot environment if Python is there. That's what we will do in the current proof of concept. This is more interesting for us to do it like outside of the operating system. We could do those restore inside of QubesOS, but then it goes to the question of but what if the host system was compromised? So doing it externally is interesting. The end goal of it all would be to do this inside of EDS, which we try to do for a while, but we will go through that also in the to-do at the end of the presentation. What is missing as of right now is the synchronization between the boot partition and the root file system of QubesOS. DOM0 thinks that some kernel initRD are deployed inside of boot. So if you don't restore boot at the same time, there will be a discrepancy between the two, between /boot and root. So that's something that we will see in the to-do later. So for the proof of concept, we restore actually all the LVMs that were backupped, but /boot is not covered for the moment. There's a ticket open inside the Wyng. So the implication and requirement for QubesOS to be able to do backup and restore the Wyng. There's a discussion that happened inside of QubesOS a long time ago related to having auto-snap LVM snapshot being created at shutdown through systemd shutdown script. I think this is really interesting, and it should probably be implemented by default. The reason to that is that it permits to user to compare root file systems, so DOM0 states between reboots. In the current example that I will give later on, we have a revertibility of two stages, so we can go back to two reboots in the past to be able to compare the content of those LVMs to see if there was compromise or anything that we would want to inspect in there. So having a root auto snap permits basically Wyng needs LVMs to be able to do backups. So doing a backup directly of the root LVM is not a super good idea in the sense that the root file system could be corrupted, even if the snapshot is atomic. Doing it at shutdown permits like all the logs to be written in the disk and synchronized before shutdown. So this is why I'm doing this. In this example here, this is a quick script. We basically remove the auto snap back if it was existing before. We create the auto snap snapshot in root auto snapback, and we clean it up. The basic here is to make sure that we have auto snap, which is the last reboot, and auto snap back, which is two reboots behind. In the case of Wyng here, we take the backup, the session of root autosnap on the next reboot. So we take the state of what was there at the shutdown of the machine, the past shutdown of the machine. So having that deployed permits Wyng to be able to do the backups. For app VMs, each app VM, private LVMs, and template VMs, root LVMs can be restored. If you attempt to restore an app VM that is live, you can restore the state inside of the private LVM, but you will have to use QVM volume revert of that app VM private storage. The logic there is that QubesOS actually rotates snapshots, and when it shut down an app VM, it takes the content that was inside of the private and puts it in private dash back. So if you want to have a state that was restored inside of private, it will be pushed inside of back, and using QVM volume revert will permit you to have that state that you just reverted inside of private. The same applies for template VMs, but template VMs normally are shut down, so it's not really a concern for us in restoring inside of QubesOS right now. The goal of what I'm talking here is to bring the attention of integrating Wyng inside of the backup restore tools of QubesOS. Here the proof of concept is actually using it outside of it, because what we want is a rescue scenario. Some of my users are actually requiring this kind of setup, and they want to be able to inspect and edit the content of the OEM image later on, so they can actually restore all the cubes, templates, Windows image in the state that it was when it was shipped to him. So template VMs and standalone app VMs are exactly the same, and they don't need, like I said, the QVM volume revert if they were not running. Standalone app VMs, as you know, is a combination of the root and private volume, so it applies the same principle as template VMs here. And here is the demo. So here we have heads booting up, Fedora 32 live image. We are using the Insurgo detached sign version because Fedora doesn't provide detached sign ISOs anymore. We're using the live normal version. It key execs into it, and now we're booting Fedora 32. That's not going to be long. Sorry for the delay. Doopy doopy doo. Voila, so we're inside of it. Here I'm showing you where the ISO was actually mounted in live, and ISOscan is actually the device where the ISO was found. This is where my scripts are actually present. Here I'm showing you the script that is automatizing the Wyng Python script. Here I'm showing you the prerequisite of paths that are needed to be known by Wyng. Here sparse write is defined because we want to write directly inside of it. We have this part that is needed to be able to unlock the Qubes Lux container, and we will verify the content of the detached sign digest that were present inside of Wyng. Here we check for the names of the directories, which corresponds to the snapshot, and here we show the difference in the script to be able to revert root autosnap directly inside of the root volume, and the commands that will be launched on those. We're launching it. We type the Lux decryption key of the volume of the install, and then the script starts by validating the detached sign digest we will show the script later on. So we see that the keys match the one that was used, the script validates that the digests are intact, and then the restoration starts. I'm skipping it like really fast here. We see here that only the root volumes had a difference. The rest of the volumes were exactly the same. And I skipped in between, like I said, just to show you what it looks like. So we see that the process to restore all the LVMs took like 40 minutes, which is quite good. So we're back in the state, a trustable state right now. Here I'm going to show you the content of the scripts, like for the validation of the signature and the signing script, and also the manifest content. Sorry, typo in the directory. So those are all the LVMs that were backupped. Here I'm showing you the total size, including Windows 10 standalone machine, which is taking 14 gigs, I think. So here is the cost of storage of all the templates and app VMs that are there. So we are at 24 gigs for a complete restorable state of the machine, including Windows 10, which was 15 gigs. Here the simple script. Basically we have a digest that is verified like against the signature at the first. So we verify the signature, which validates that the digest is good, and then we validate the digest itself. That's what was the first step of the automatized script earlier. Here the script like that is just searching for vol info, manifest info, and the boot backup that I did, and we output inside of SHA-256 sum, and then we detach sign that digest. Now we're looking at the digest itself. So you see here that measurements are taken like for all of the files that are important for the Wyng. So we can guarantee at restore that the state is good prior of reverting. Here I'm searching like for a manifest, a Wyng manifest. It won't be long. This is how it looks like. So it's a chunk mapping with measurements of all the pieces that this volume is taking charge. Voila for the demonstration. So here we're not completely done because the boot restoration is not made as of right now. So it's kind of tricked. My demo is tricked because like /boot was detached sign by head, so we knew that the state was good. The problem with that is that domain 0, the root file system, QubesOS domain 0, is actually the one being responsible to deploy the upgrades. So dom 0 is responsible to having like the verification digest inside of RPM database. So let's say that you revert in a state that was like 1 year ago, that would not work because like the state of /boot would be more recent than the state of the root that is reverted. So we need like to find a way to actually store that content inside of LVM. That will be done, but it's not done yet. For heads, restoring /boot will come with some problems because There are counters that are stored inside of /boot which will be out of sync. So it's a question of documentation or trying to deal with it. We could delete actually those counters so that Eds pick it up and ask the user to sign it again. Eds as of right now unfortunately doesn't support thin LVM with a lack of LVM provisioning tools. It's quite complicated to actually integrate it. If you have any insight, jump in. That would be really amazing, because if Eds has LVM provisioning tools integrated and the Wyng extract bash script works as intended, then we would be able to actually restore local backups, like the proof of concept that I showed you. This is another story completely if we want to restore from a remote station. That's possible. I am doing a proof of concept right now with rsync.net, which are open to create read-write account with a sub-account which is read-only. So you're actually able to store your archive as a read-write account, and then it permits us to deploy a read-only virtual machine already provisioned with the public key to be able to restore remotely. And this is where it gets really interesting, because let's say, for example, that there is a ReactOS template that is now existing, or the user wants to actually restore his Fedora template to Fedora 34, but doesn't want necessarily to download the new template and everything. He could just restore directly inside of his LVM the right state. And same thing applying for disaster recovery over a remote SSH server with the detached digest already signed and reviewed and validated. Here I'm giving you a link to go to Wyng extract, which is permitting you to restore archive. I made a bug report recently. It's not perfect yet. This script is less tested than Wyng, which is made in Python, but we're going there, and it's looking good. Like I said, here if you check the contract by the DOM0 to see if the integrity of the kernel, Xen and everything is good, and you didn't restore /boot, there will be a discrepancy. So there is a need to have /boot and DOM0 in sync at all time. For the rest I already covered. It's just more details. I think that's it. I hope you enjoyed the talk, and I'm looking forward to have your questions, to have restorable state, and maybe, who knows, QubesOS maintaining SSH server to be able to restore your state directly from their SSH server in the future. Who knows? Thank you.